So let us go in brief about how to find the hydrostatic force on a submerged surface. Okay. So if you remember, what was the purpose? The purpose was to reduce the action of fluid on the surface to one force only. So we should determine first what is the magnitude of the force, what is its direction, and what is its line of action. Okay, so first, whenever we want to determine the magnitude, we need to do an integral procedure. Why? Because here you have the pressure is acting in a perpendicular way to your surface, and it's varying. As you are going in depth, your pressure will increase. So you don't have a uniform distribution over your surface. You have a variable pressure over your surface. So to find the total force, you should do an integral procedure. Similarly, if you want to determine what is the line of action of the force, what is the condition that will allow you to find the line of action of the force? The condition is that the moment produced by the distributed load, okay, about any axis, should give me exactly the same moment produced by the resultant force. So this is in summary the procedure. Now, in which frame to work? We can work in several frames, okay, because as whatever the frame I consider, at the end I will have the same final result. So you can consider, for example, to locate the direction, to locate the point of action of the force, you can maybe work with a frame at the center of gravity of the surface. So this is X passing by C, and this is Y passing by C. And then you can locate the point of application with respect to this frame. Or also another possibility is to consider the frame for which the origin is starting at the free surface. If I consider this is my free surface, and I have the submerged surface that is inclined, since my submerged surface is inclined, so it's doing a certain angle theta with the horizontal, I can take as origin the point as the point of intersection of the free surface and the inclination, which is the plane containing my surface of interest. And then I can define the following frame. I will take Z perpendicular to the surface. Y axis is Y and X axis will be along the surface plane, okay? And Y will be along the inclination like this. And X will be perpendicular to Y, okay? So if you want, here you have two views. This view is it's the XY plane viewed from above. So if you look at from here, from above, you will see this plane. And if you take the profile view, you will have this, okay? And now we want to find what is the force that can replace the water action on my surface, or any fluid. It can be any fluid, just I should know its density, and I can determine what is the force it will exert on my surface. So as a recap, to find the resultant force, I should integrate over the area, integral over A of PdA. And as we said, how we can find the pressure at any point, at any depth, okay? The pressure at any depth is equal. So if I consider any depth H, then I should add the pressure at the surface, which is P0, plus rho GH. And now I will integrate pressure over the area. I need to do an integral procedure because the pressure is function of the height. So as I am going downward, as the depth will increase, the pressure will increase also. So now, when I do the integral procedure, if you remember, we can replace H, we can relate it to a coordinate along the surface plane, which is Y. So as you can see in this figure, Y is related to H by putting just that Y sine theta is equal to H. And then now we can replace in our equation here H by y sine theta. And when we perform the integration, we know that P0, rho, g, and sine theta are fixed. So we can just, by take them outside of the integral, we'll just have inside the integral here for this term, what will remain is just, we take rho g sine theta into factor, and we'll get inside the integral of y dA, okay? Of course, plus the integral of this term, so plus integral P0 dA, since P0 is a constant, so it's plus P0 times A. And now, what is the integral of y dA? So remember, whenever you see this, this is related to the centroid of the area. And this term is called first moment of area. So I can replace the first moment of area by the y at centroid times the total area. And now this is my final result for the resultant force. If I take the area into factor, it's P0 plus rho g hc times, okay? Now, this term physically, we said that it represents what? This term represents the pressure at the centroid. Because if I know where my centroid is, how can I calculate the pressure at it? I just need to know the depth h of c, which is hc is yc sine theta. So we can replace sine theta yc by the depth of c. So the pressure at c will be due to the column of the fluid above c plus the pressure at the free surface P0. So we can say now, as our first objective was met, we just found that the resultant force that will replace the system is equal to the pressure at the centroid of the area times the S. Now, the challenging part is to determine the point of application, okay? And we started this part together last time. So, whenever we want to find the point of application, we should find two equivalent systems. We should define the force Fr any way to produce the same moment resulting from the distributed load. So this is the equation that will allow us to locate the point of action of the force Fr. And since here you have for your surface, if you go back to this figure, okay, your pressure distribution is producing moments about two axes. Your resultant force will produce a moment about, because it's along Z, Fr is along Z, it's perpendicular to your surface. So it can produce a moment about X and it can produce a moment about Y. So I should find what is the location of Fr anyway to have the same resultant moment of the distributed load about X and the same resultant moment about Y. Okay. Now, concerning if you want the moment sign, if it's positive or negative, all you have to do is to apply the right-hand rule. Okay. So from the right-hand rule, since your force is directed here, it's perpendicular to the surface, so towards the screen. If you put the force towards the screen, you will get in this figure, you will get a negative moment about Y and a positive moment along X using the right-hand rule. Okay, but don't worry, we don't care a lot for the sign. You know why? Because it will simplify from both sides. And if you put, let's say here, the moment about Y axis is negative. Okay, when I want to put the condition of sum of moments, it will be a negative moment for the resultant force and a negative moment for the moment of the distributed load. So minus minus can be cancelled out. This is why you don't care a lot here for the sign of the moment. Okay, so let us start with which axis. We will start by finding the position of the resultant force any way to produce equivalent system about x-axis. So I should produce the same moment about x. This is why what I should do first, I should find the total moment created by pressure forces about x-axis. You can see it better in this figure here. Okay, in this figure, you can see this issue or also you can see it in both figures, because look, how is x-axis here? X-axis is perpendicular to YZ, okay? So when you do sum of moments about X, okay, your forces here will tend to do this, will tend to rotate in the counterclockwise direction. So it is along a moment along positive Z axis. So I will say that the moment produced by FR about X axis is plus FR times, I should find, my purpose is to find what should be the position of FR, what should be this distance Y prime, in order to give me an equivalent moment. So this is the distance I am looking at. I am trying to find what should be the value of Y prime from the surface in order to produce an equivalent moment about X axis. So this distance is Y prime. So I put FR times Y prime should be equal to what? Should be equal to the total moment created by the distributed load about O. Okay? So, you know, since I have the distributed load is not uniform, I have to divide into small parts. So I should take an elementary force dF. Okay? So I take a very small area dA. Let's say here, I will take an area dA that is at constant distance from O. So let's say it's Y. All this element, this whole element, is at a certain distance Y from the x-axis. So if I am interested into what is the moment of dF about X, what should I do? I should simply do dF times Y. Okay? So I can write that the elementary moment of a small force of the distributed load is equal to dF times Y. And since I want to find the total moment, I should integrate over the surface. Okay? And then to be able to perform the integration, I should replace dF by its corresponding value. We know that dF is what? dF is the pressure acting on this area times dA. Okay? And already we have seen together that I can replace the pressure term by what? The pressure term is P0 plus rho GH. Okay? So now I have to integrate. So the total moment M, which is equal to the resultant force FR times Y prime, which is the distance I want to find, should be equal to integral of the pressure term times dA. And now let us see what is integral of pressure over dA. Of course, times, don't forget times Y to obtain a moment. So let us develop this term together. So this is our equation, okay? This is the equation which will give us Y prime. Y prime times FR equals to integral over the area of YP dA. And now I will replace P by P0 plus rho GH. And again, since I am integrating over the area, I should introduce a variable related to A, which is Y. So I will replace H by Y sine theta. And now let us see what do we obtain. We have Y prime times FR equals to integral over A of P0Y plus rho G Y square sine theta dA. Okay. Now let us integrate term by term. For this one, for the first one, I'm doing integral over the area of P0Y. Since P0 is the pressure at the surface, it's a constant. I take it outside of the integration, and I will get P0 integral Y dA. And again, this is the first moment of area, which we can replace by Y at the centroid times A. Okay. Now, what about the second term? For the second term, rho G constant, sine theta constant. If I take them outside of the integration, I will get rho G sine theta times integral y squared dA. This is called the second moment of area about x-axis. And sometimes we symbol it as Ix. Or simply in some books we just call it Ix because it's about x-axis. Okay? Now, how we will try to simplify a little bit this formulation. Okay? So in order to do this, first we have that we need to find what is y prime. Okay? So we have y prime times fr is equal to this term is yca times p0. Now we will try to do the analysis of what is Ixx. You know that Ixx is defined as the second moment of area about x-axis. If you remember from statics, I think you have covered this in statics, okay? If I know the inertia about any axis, x, and I want to relate it to the inertia about an axis passing by the centroid of the area, okay? So let's say this is the centroid C of the area. I want to relate the inertia about x-axis passing by O and the inertia about x-axis passing by the centroid. I can write that inertia about x-axis passing by the origin O is equal to inertia about x-axis passing by the centroid C plus the area of the surface times the distance between the two axes, the perpendicular distance between the two axes I am considering. I will call it d squared. So d represents the distance between the two axes. And here, since I'm considering the distance between the x-axis passing by O and the x-axis passing by C, this distance is y of C, which is the coordinate of the centroid. So I can replace d by yc. So I will get the following. I will get that if I replace back in my formula, I will obtain a very interesting result. Let us see it. So we have y prime, which is the location I'm trying to find. I don't know it, okay? Times the resultant force. We have just in the previous slide found how to get Fr. Fr is the pressure at the centroid times the area of the surface. So y prime times Fr should be equal to this term. I will keep it as it is, yc times A times P0. Now I will replace the inertia about x-axis passing by O. I will replace it by the following term to see what I will obtain. So I will have plus rho g sine theta times Ixx, which is x passing by O, can be replaced by first here inertia of x-axis passing by the centroid, okay? And I will have to add another term, which is plus rho g sine theta times yc times A times yc squared, okay? Now, if you just look well at your terms, okay? Here I have yca times P0, and I have here rho g sine theta A times yc squared. What can I take into factor between these two terms? These two terms have in common yc times A, okay? Let us take yc times A into factor. So yc times the area of the surface times P0 plus rho g sine theta times yc, okay? And again, what is sine theta times yc? I can replace it by h. So this term represents what for you? P0 plus rho GHC represents what? This will give you, okay, This will give you the pressure at the center. P0 plus rho GHC will give you pressure at center C. And when you multiply the pressure at center C by the area A, this will give you what? This will give you FR, because we have seen that FR is PC times A. So now I can say that Y prime FR can be replaced by YC times FR plus this term, the remaining term here, which is rho G sine theta times inertia of the x-axis passing by C. If you please, if it's not clear, I can repeat. Any question on this? Okay, so this is my final result. As you can see here, I know all parameters except what? Except Y prime, because FR is pressure at the center times area. I calculated in the previous stuff, I know it. The position of the centroid, I know it. It depends on the geometry of my surface. I can get it. The resultant force, I know it. Rho G and theta, all of these are given. Now, concerning how to calculate this term, don't worry about it. This term, we will always give you common geometries: rectangle, triangle, circle, and we'll see together now in a formula sheet what is the formula of inertia for each shape. So let's say it's a circle, you go back to the formula sheet, you look, what is the inertia of a circle about an axis passing by its center? And then you can replace here in this equation. Okay. Now, since I am interested into Y prime, all I have to do is to divide. I will divide both sides. So I will take FR to the other side. So if you divide here by FR, you will get YC plus rho G sine theta IXX over FR. Okay. So this formula will give you what is the position of the center of pressure of your force with respect to y-axis. And if you do an analysis of this formula, you can see that your point of application is always below the center, below the centroid of the area. Why? Because look, this is a positive term, rho G sine theta. Theta is smaller than 90. So rho G sine theta times inertia over FR. This is positive. Okay. And even if theta is larger than 90, you know that for theta between 0 and 180, sine is positive. So for any angle I consider, this is a positive term. So this is, let's say this is C, location of C. So to find Y prime, I should take Y of C plus a certain positive term. So my point of application will always be below center C. Okay, and this is physically logical. Why? Because as I move downward, the pressure is increasing. So it's logical to have the point of application of the resulting force below the centroid of the area. Okay. Now, in some particular cases, if you remember, we said that at the surface level, we can have any pressure that is imposed. Now, if it is the atmospherical pressure, so if I have PA, in general, I can say that P atmospheric is neglected compared to the pressure in the fluids. Okay, so then if I have very small pressure over the surface, what can I do? I can then replace FR by rho, because you know what is FR? It's pressure at the center, okay, times area. So if P0 is negligible, then I can replace PC by what? By just rho times G times H of C. And what is H of C? H of C is YC sine theta. So then I can replace FR by rho times G. And of course, we should not forget to multiply by A. So by rho G YC sine of theta times A. So now in this particular case, what will happen? You can do some simplifications. You have here rho g sine theta in the numerator, and also in the denominator you have rho g sine theta. Okay, so you will end up only with the remaining terms will be ixx, which is the x-axis passing by the centroid, inertia about x-axis passing by the centroid over the area times yc. Okay, so please keep in mind this formula is only valid if the pressure at the surface level is negligible compared to the pressure in the fluid. However, if it's not the case, so if you have, let's say here, a fluid, or if you are imposing any high pressure at the surface, then you should go back to this formula. This formula is always applicable. Okay, this formula is only applicable. So this is general one. This is a general one, and this is only applicable for negligible values of P0. For negligible values of P0. Okay, let me check your chat before we proceed. Okay. Look, I will post all of this on Blackboard for you, okay? Yes, we are doing the same approach, but now we are just considering a different coordinate system. And you know why? Because in a lot of problems, you will find these formulas. So I want you to be familiar with both, okay? So again, we'll obtain the same result because look, here, if you take, for example, if you considered instead of y-axis starting from O, if you consider y-axis at the centroid, okay, you can consider your origin at the centroid. And if you take it, let's say you want to take it upward, okay, you know what will be your result then? If this is the centroid and your axis is up, your result will be that the point of application is below the centroid, so it's a negative. It's minus just this term. So if you work in another frame, if you work in the frame centered at the centroid with y-axis upward, you will get exactly the same result. You will just have that y prime, y center of pressure, okay, is because you are counting it now from this level and y is considered positive upward, then here you will get minus rho g sine theta. So I need you to know both because in some books you will have this formula, in other books you will have this one. So just to know that it's the same thing, just we are changing the reference of y of the point of application. But whatever is the frame we take at the end, of course we should obtain the same location. So if we considered the position from the point at the free surface, we'll get the following. We'll get y of the centroid plus this term because my point of application is below the center of pressure. However, if I considered, let's say, the origin at the center point, and if I take y up instead of down, then I will get minus rho g sine theta, inertia about x-axis passing by the centroid over fr. So exactly the same result, okay? So just be familiar with all equations because depending on the book, you might have different notations, okay? Any other question? Concerning the derivation, it's good to understand it, okay? Please try to understand it. In the exam, of course, you can directly use the result. But just for you to know how what is the idea, it's important. You will not have to do the derivation, but you should understand the concept. You should understand that the force Fr to replace the system should produce the same moment about O. Okay, this is the idea that you should understand well. Okay, and now we have found what is the location along Y, but still, as we said, we should also ensure same moment, not only about x-axis, but also about y-axis. So now if I repeat the same procedure, okay, I will do to find what is the distance to displace the force along x, then I will go to the equation now of moment. The moment about y should be the same. So it's exactly the same procedure of derivation, but now I want to determine what is the position along x of my resultant force. So it will be x prime times fr is equal to integral over the area of x times the elementary force df. We replace now df by pda, and we will do exactly same procedure. Replace p by p0 plus rho gh. Now just what will happen with your terms, you will get instead of integral y dA, you will get integral x dA. And integral x dA can be replaced by x as the centroid times area. And now here,